Hi everyone, welcome back. Today's topic is monopolistic competition. Now, you need to know that name. I'm going to give you another name as well and be upfront with you. I don't like this name. Whatever committee gave names to all the concepts in economics met long before I was on the scene, so I didn't have a say in this. But if I did, I would have voted for differentiated competition. And you'll see why in a minute. But nevertheless, the name that is most commonly known by is monopolistic competition. I just don't like it because it takes the name of one market structure, competition, and then just sort of melds it together with the name of monopoly, which is on the opposite end of the spectrum. And I guess to their credit, it is somewhere in between. But at any rate, that's the topic for today. If you're thinking about that overview document that I gave you before, it shows these various market structures in a spectrum from perfect competition to monopoly, and then monopolistic competition is right here. Right, so basically, we're working on this column right now. We're going to talk about those three characteristics: number of firms, type of product, barriers to entry. And then you can see how it's similar and how it's different from perfect competition or the other market structures that we will talk about eventually. So, the three characteristics. There are still lots of firms, right? So there are still many firms. So that's the same as there was in perfect competition, right? Lots and lots of firms. Number three, in terms of barriers to entry, is still the same. There are still low barriers to entry. Right, so that's the same. So then the one thing that is different is that, under perfect competition, we said all of the products were homogeneous, right? They were identical. We're not going to say that anymore. We're going to relax that assumption and say that there are similar but differentiated products. Hence why I think this could be called differentiated competition. That is the most important change in the characteristics, right, or assumptions going into this model, and that's what gives us a little bit different result. So where perfect competition was actually really, really rare, right? The number of examples of perfect competition in the marketplace are pretty limited. The examples of monopolistic competition are abundant. And so how many of the things that you buy are there close substitutes for made by other companies, where they're similar but they're different? So if you have a favorite hoodie sweatshirt, right, it might be made by Nike, it might be by Champion, it might be by Under Armour, it could be by Adidas, right, or any number of other companies make hoodies. Are they identical? No. They're not identical. The fabric's a little different, the cut, the design, especially the logo, right, that goes onto it, different. But at the end of the day, are they similar? Pretty much. So that's an example. So a lot of shoes and clothes and food products, and there are lots and lots of examples of monopolistic competition where there are many firms making similar products, but those products are differentiated. So that's the market that we're going to talk about. And if you are in a monopolistic competition environment, then you are what we call price searchers. Remember, in perfect competition, we said the firms were price takers. The market determined an equilibrium market clearing price, and you could either sell at that price or not. But you couldn't charge a premium over that price. Now, if you can differentiate your product, then you could try to charge a premium, right? You could choose a price that's a little different than your competition. And the more you can differentiate your product and show, impress, prove to people that your product is better, superior, different than the others, the more you can try to charge for that characteristic. So because of that, we say they can choose both the optimal output level and the optimal price. Now, With that being said, they have to connect, right? You can't just say, I want to charge a really high price and I want to sell millions and millions of units, right? That only works if your demand curve allows for it. So when we say there are price searchers and they can choose the optimal price and the optimal quantity, which we're going to call Q star and P star, they do still have to be related or connected by the demand curve. So you can choose to sell at a really high price and sell this quantity. So you could choose P1 and Q1, or you could choose, let me change colors up here. You could choose this price, we'll call it P2 and Q2, right? You could choose to sell at this point on your demand curve. Or you could choose to sell down here, right, at P3 and Q3, right? Or any other thing. But notice that they are connected. So the demand curve relates them together. So you can't just choose this point out here, right? Which has, you're like, I want to sell at a very high price and I want to sell a whole bunch of them. That is not an option, right? So you choose P star and Q star, but you choose them in a way that they are connected by the demand curve, right? So you can choose from any one of the points on your demand curve. Now, as for how we do that, it's actually the logic and some of what we do is very, very similar to what we did in perfect competition, but the graph looks different. So the graph looks different because if you can differentiate your demand, or if you can differentiate your product, your demand curve looks different. Some people will prefer your product over others. And so your demand curve is downward sloping. Now, the more similar your competitors' products are, the more elastic your demand curve will be, right? The flatter your demand curve will be. But it'll still be downward sloping. So if you have a favorite hoodie, right, or a favorite pair of running shoes, right? So if, I like Adidas shoes. They seem to fit well. They're comfortable. I like them. And so if the Adidas and the Nike and the Saucony and the Asics were all the same price, I'd choose the Adidas. If the Adidas were a couple bucks more, I'd probably still choose the Adidas. But if the Adidas are $30 more, I might rethink some of those substitutes. I might say, I'm willing to try a different brand, right, and experiment again if you try to charge too much of a premium for the demand that for the product that I prefer. So your demand curve will be downward sloping to the more you can differentiate your product and convince people to prefer yours over others, then right the steeper that demand curve might be. At any rate, it's downward sloping. And so what that means is that then our graph will look different. And two, our marginal revenue curve will look different. So if you recall, in perfect competition, right? So recall from before, in perfect competition, we had two graphs, right? You had one for the market and one for the firm. And so you had a market supply and demand curve. And that, we should label these as well, right? That created a perfectly elastic demand curve for the representative firm. And in this situation, because demand was horizontal, it was also the marginal revenue, right? Demand equals marginal revenue. That was specific to the situation where demand was horizontal. So you sell one more unit, you sell it at the same price, it brings in that much additional revenue. You sell one more unit, on the line, you sell it at the same price, it brings in that much more revenue. What happens when the demand curve is downward sloping is that I could sell, let's see, I have I think I want to do this down here. Let me do this on the side here. I have a special little graph set up for it. This is your demand curve. And so if I picked P1 right here and I sell Q1, then my total revenue, I can make this bigger, right? My total revenue would be right here. Right there. So we'll say total revenue equals price times quantity. So the money I make, right, from selling is P1, the price I charge for each of those units, times Q1, right? Now, what happens if I want to sell more? I'd say I could sell more than I did before, but in order to do that, I have to lower the price. Right? What if I want to sell at this point on the demand curve? I can sell Q2 units, but in order to do that, I have to sell at a lower price. So how does my total revenue change? Now, my total revenue is still the area inside that purple rectangle. I mean, if you add in the axes, the black lines, the black axes plus the purple lines there give you a rectangle. That would be your total revenue, right? Total revenue to, let's say, P2 times Q2, right? It would be that area. Now, how does that differ from the first one? Whoops, what happened here? Come back. So how did that change? I have additional revenue over here because I sell more units, right? So my total revenue goes up by the green rectangle, but in order to sell more units, in order to get to Q2, I had to lower the price, which means I lost that premium on the original units. Right? So now, in order to sell Q2, I have to lower the price, so I don't make the money in the original total revenue box that I've now shaded in that section red, but I do gain the green rectangle. And so my marginal revenue, the change in my total revenue, is sort of the net effect of those two. In this case, when moving from Q1 to Q2, the green rectangle is bigger than the red one, but not by a ton. So it looks to me like the marginal revenue, the net effect of those would be about here. Right? And we could do it farther up the demand curve. Let's just do one more example, farther down here. What if I were moving from this point to this point? I didn't mean for that to hit necessarily. Right? So if I wanted to sell more, I have to lower the price. And so thinking about the trade-offs, I would gain additional revenue by selling more units, but I would lose the premium on all of the previous units, right? So in that case, my marginal revenue would be negative, right? So it might actually be down here, right? The net effect of that red rectangle and the green one is a negative effect. It might be down here. So what we find is that the marginal revenue curve is below the demand curve and moves faster, right, or falls faster. So marginal revenue is below the demand curve and falls faster. So what that means in our graph then, if this is the demand curve, then this is what the marginal revenue curve looks like. So that's the biggest change in moving from perfect competition to monopolistic competition. Our graph looks different. We have a downward sloping demand curve, and therefore we have a downward sloping marginal revenue curve. Now, let's get to one more. I should have kept track of how long we're going here. Let's look at this situation. How do we find profits? Right? What happens? How do we tell if a firm is earning a profit? Well, we use the profit maximizing rule, marginal revenue and marginal cost. Right? That's the same. The profit maximizing rule is the same. In fact, much of what we do here is the same as what we did in perfect competition. It's just on a graph that looks different. So if here's your demand curve and here's your marginal revenue curve, then what do we need? If we want to follow the profit maximizing rule, we need the marginal cost curve. So you add in the marginal cost curve. The profit maximizing rule says you produce as long as marginal revenue is greater than marginal cost, and then when it's not, you stop, right? So this is Q star. Oh, one last thing I should have mentioned up here. The marginal revenue curve is below the demand curve and it falls faster. For purposes of sketching it, in the case where your demand curve is a straight line, if it's linear, then your marginal revenue will also be a straight line, and it will be the angle bisector. So those two angles will be the same. Or if you extend the demand curve all the way down to the horizontal axis, the distance of those two line segments should be the same. Now, when you draw this, on a homework or in practice or on an exam, I'm not using a ruler and a protractor. I'm not interested in that level of precision. But I do want you to understand that when you're drawing it, it should look something like this, right? If this is your demand curve, then the marginal revenue curve should look something like that. What I'd rather not see is if this is your demand curve, that your marginal revenue curve looks like this, right? Or they're not going to be parallel, right? They're going to have a different slope. The marginal revenue falls faster, and so just try to roughly approximate it. But it's not. I'm not interested in checking your homework with a protractor. That's not the goal here. All right, so to jump back here at Q star. We use the profit maximizing rule to find Q star, and then we said once we've identified that, they can also choose both Q star and P star, right? So how do we find P star? Do we take that dot I just made and go straight over to the left? Well, no, right? The demand curve tells us at this quantity, what price can I charge, or at a particular price, how many can I sell? So you want to find the point on the demand curve that connects them. So once you find Q star, you go up to the demand curve, and that will give you P star. And that's how you find the optimal output level and the optimal price. If you guys have any questions so far, you're going to have to shoot me an email, right? Or check in. I'm happy to go over this again, but if it's making sense and you're good, we'll roll on here. To our next question, and you may realize that this is the same question we asked when we talked about perfect competition, right? Next up, once we found Q star, we said, is the firm earning a profit, specifically an economic profit? And the short answer is, with the graph we had, I don't know, right? So let's start with a fresh graph here. Here's my demand curve. I'm going to put it's downward sloping, so my marginal revenue curve goes under it and falls faster. I want to find Q star, so I need marginal revenue and marginal cost. So I'm going to draw in my marginal cost curve, and that gives me Q star. And with Q star, I go up to the demand curve, and that's how I find, all right, what's my optimal price? My profit maximizing price. I read off the demand curve. There it is, Q star and P star. And now our question, is this firm earning a profit? Well, the answer at this point is, I don't know. Now, and maybe right now you don't know because you're new to this game, but I can say I don't know because I don't have enough information. Now, if it is, I will know that based on the average total cost curve. So in order to answer that question, use the average total cost curve. Now, you could do it with total revenue and total cost as well, but we don't have those numbers. We can't answer it with marginal revenue and marginal cost because that just tells us the revenue on the last unit and the additional revenue on the last unit and the additional costs based on the last unit. But the average numbers will help us. So remember, if you were running a lemonade stand and you were trying to figure out your profit, you would look at your total revenue and your total costs. Right? How much money did I bring in and how much money did I spend? The difference, if it's positive, that's your profit. Well, with a little algebra, you can divide both sides by Q, right? And you can get profit divided by Q, right? So that's basically average profit, right? Profit per unit. Is total revenue divided by Q. Well, that's average revenue, right? So you can distribute that divided by Q, right? 1 over Q times the times total revenue minus total cost, and distribute the Q across, and you get 1 over Q times total revenue minus 1 over Q times total cost, right? So total revenue divided by Q minus total cost divided by Q. So profit per unit is going to be average revenue, right? Or revenue per unit. Well, that's just price, right? Because if you sell every unit at the same price, then the average revenue, total revenue divided by Q, that's going to be price. How do you find total revenue? You take price times Q, right? So there's price minus total cost divided by Q. Well, profit per unit is going to be your price minus your total cost divided by Q. That's average total cost, right? If you think back to what we were doing in the production and cost chapter. So if we have the price and the average total cost curve, then we can find the profit per unit. And since we know they're selling Q star, then that's what we would need to solve the profit maximization part. So I'm going to draw in the average total cost curve. And remember that the marginal measure always drags the average along. So your average total cost curve might look like this. It hits its minimum when marginal cost goes through it. There's your average total cost curve. Now, at Q star, I can look at this and say, all right, at Q star, I'm selling every unit for that amount. And on average, each unit cost me this much. So I'm earning this much profit per unit. And I'm selling Q star units. So this area right here represents economic profit. So now I can answer this question. Is this firm earning an economic profit? In this case, yes. The firm is earning an economic profit. Do you see how this is similar? This is the same thing we did with perfect competition. Only now we're doing it in a different market structure. The graphs look different. The concepts are the same. So when you think back to the characteristics of monopolistic competition, there are low barriers to entry. And with low barriers to entry, people can jump in and start competing away those profits, pretty easily. So that's what we would expect to happen. Only how it happens on the graph, what it looks like on the graph, is going to be a little bit different. So I said here, economic profit invites entry. Right? That's the same as before. Now the entry looks different. Right? Rather than saying there are more competitors, producing it, and so the supply curve shifts out. Instead, we have to think about what the competition looks like. So in a given town, if there are a bunch of coffee shops, right? So a textbook that I used to use used Starbucks as an example of a monopolistically competitive firm. Right? Is Starbucks coffee differentiated from its competitors? Is it a little different than Dunkin' Donuts or Caribou Coffee or the coffee from Wegmans or coffee from Tim Hortons? Sure. But is it still coffee, right? Is it similar? And this maybe depends on your preferences, how similar, how close you think the substitutes are. But you can make the argument that it's all coffee, right? That it's all similar, but it's differentiated. And so the question is, whenever a new coffee shop opens up in town, what happens at the other coffee shops? Or if you want to use pizza, when a new pizza shop opens up, how does that show up? What changes for the existing pizza shops? So let's look at Dunkin' Donuts, right? So we'll say this is Dunkin' Donuts coffee, right? And there's some demand for this, right? There's some marginal revenue curve. It's downward sloping, right? It's below the demand curve and falls faster. We need the marginal cost curve. I'll try to go quickly. You can pause this if you need to catch up in your notes. I'm just giving us a fresh graph to work with here. Now, I want to show this Dunkin' Donuts earning an economic profit, right? So I'm going to draw in an average total cost curve. That's below the price, right? Hits its minimum where marginal cost goes through. That means at Q star, it's the price it sells every unit for is higher than the average cost per unit, so it earns an average profit of that height times the number of units that it sells. That's Q star. And so you have an economic profit. Right, so that just catches us up to where we were before. But what happens when Tim Hortons opens up in town? Now, right, there's economic profit. Economic profit invites entry. And now Tim Hortons opens up nearby. Or maybe Tim Hortons and Dunkin' Donuts were both there and you decided to get entrepreneurial and open up an independent roasting, coffee shop. Whatever it is, economic profits invite entry. Somebody new comes into town. And what happens if across town, there was Starbucks and Dunkin' Donuts and now there's a Tim Hortons? Well, presumably some of the people who used to buy their coffee at Dunkin' Donuts or Starbucks now go to Tim Hortons or now go to your independent shop. Not all of them. Some of the people preferred Dunkin' Donuts, right? Some of the people preferred Starbucks. Some of the people liked them because they were close and convenient. It was on the right side of the road as they went to work or school, right? It was if you're walking in a city, it was close to where their apartment building or their office building, whatever it is. But now Tim Hortons opens up, and for some people, that particular taste of coffee is preferred. That environment is preferred. That location is preferred, right? Whatever it is. And so when some of the people who used to frequent Dunkin' Donuts now go to Tim Hortons, how does that show up to Dunkin' Donuts? Well, that's a decrease in their demand curve, right? So the demand curve shifts to the left, right? We could say as a result of new entry, new competition. As a result of new competition, the demand for Dunkin' Donuts shifts to the left. And if the demand shifts for the left, then what happens? Well, now the marginal revenue curve shifts to the left as well. There's marginal revenue 2. And here's Q star 2, right? There's a new, and so with more competitors and a lower demand curve, there's now a new profit maximizing output level. And that goes up here. Here's our new price, right? We'll call this P2, P star 2, Q star 2. Now, is this firm still earning an economic profit? It's a little bit hard to see. It's a little bit messy. But in our case, yes, right here, they're still earning an economic profit, right? Even at Q star 2 and P2, it's higher than average total cost 2. So they are, but their economic profit is much smaller. Let me put a different color in there in case that's hard to see. I'll put some orange stripes in there. That's the economic profit too, right? So is that green box with the orange stripes in it. So competition is eating up their economic profit. And I wish I had one more blank slide in here. I just need a little more space. Let me just do it up here off to the side. Eventually, now there's still economic profit there, right? In the economic profit too, the smaller bright green box with the orange hashtags. In the long run, right? That still invites entry, right? That's still economic profit. That's still a return above and beyond a normal return on investment. And so that would invite more entry, and you'd expect in the long run to end up at the point where they're just breaking even, right? Which should sound pretty similar to what we did in perfect competition, right? So here's Q star, and here's P star. And so in the long run, you'd expect them to be at the point where they're just breaking even. And what that looks like in monopolistic competition is that the price that they sell it for is exactly equal to the average cost. And so we would label this the point, we would label this the point of break even. At least in an economic sense. They may still earn an accounting profit, but in the economic sense, at this point right here, they're just breaking even. And so in monopolistic competition, can you have economic profits? Yes, for a while. But economic profits invite entry. Entry is going to tend to compete away those economic profits until they are, in the economic sense, just breaking even. So there's a lot to chew over. That's our start. We're going to pick up with this next part, what happens when there are losses. But we'll save that for a separate video.